In this lesson, we're going to be focusing on evaluation of limits using L'Hopital's rule. So, for you to evaluate a limit using L'Hopital's rule, upon direct substitution, you must get 0 over 0 or infinity over infinity. This is the only condition that will allow you to apply L'Hopital's rule to a given limit. So, let's consider this question that is written here. We have limit as x tends to 0 of sin x over x. So let's plug in 0 to this given limit. So you have sin 0 over 0. Now sin 0 is equal to 0. You have over 0. Therefore, we can apply L'Hopital's rule. So then we have limit as x tends to 0. Now for L'Hopital's rule, we are going to differentiate both the numerator and the denominator. And another condition is that it must be in a quotient form, like it must have numerator or denominator. So there is another condition for you to apply L'Hopital's rule. So let's differentiate sin x. If we differentiate sin x, we're going to get cosine x. Then over, if we differentiate x, you're going to get 1. So let's plug in 0 into this equation. So we're going to have cosine 0 over 1. Cosine 0 is equal to 1. Then we have 1 over 1, which is equal to 1. So we have that the limit as x approaches 0 of sin x over x is equal to 1. Let's solve another question. We have to solve limit as x approaches 0 of 1 minus cosine x over x squared. So let's plug in the value of 0 into this expression. We're going to have 1 minus cosine 0 over 0 squared. Cosine 0 is equal to 1. 1 minus 1 is equal to 0 over 0. So we can apply L'Hopital's rule. So we're now going to have limit as x approaches 0. The differentiation of 1 minus cosine x. Now if we differentiate this one, which is a constant, we get 0. Now let's bring out this negative sign. If we differentiate cosine x, you're going to get negative sin x. So this will be over. If we differentiate x squared using power rule, we're going to get 2x. So this is equal to minus times minus is plus. We have sin x over 2x. But you see that if you plug in 0 here, you still get 0 over 0. So let's do another differentiation. So you have limit as x tends to 0. Now if you differentiate sin x, you will get cosine x divided by, if you differentiate 2x, you're going to get 2. So if you plug in the value of the limit, which is 0, we are going to have cosine 0 over 2, which is equal to, cosine 0 is 1 over 2. And then we see that the answer is equal to 1 over 2. Let's solve more questions. Let's evaluate this limit. Limit as x tends to 0 of e raised to power x minus 1 over x. Now, applying 0 to this, that is direct substitution, we're going to have 1 minus 1 over 0, which is equal to 0. So we can apply L'Hopital's rule. So we have that limit as x approaches 0. If we differentiate e raised to power x, you have e raised to power x. Negative 1 will tend to 0 because it is a constant. Now if we differentiate x, you are going to get 1. So substituting x equals to 0 here, we have e raised to power 0 over 1. We know that any number raised to power 0 is equal to 1, and then 1 divided by 1 is equal to 1. So 1 is the answer to this question. So let's solve another question. Limit as x approaches 0. We have x minus sin x over x raised to power 3. Now upon direct substitution, this will still give us 0 over 0. Alright, so let's solve it. We have limit as x approaches 0. Let's differentiate the numerator. If it differentiates x, you're going to have 1 minus, if it differentiates sine x, you get cosine x. Then this will be over s cube upon differentiation will give 3x raised to the power of 2. Alright, now for the fact that this denominator will be equals to 0, we need to differentiate more. But then let's confirm if also the numerator will be 0, so it will be 0 over 0. So let's go ahead and differentiate again. So if we differentiate 1, it will be 0. If we differentiate negative cosine x, we are going to get sine x. Then over, if we differentiate this, we are going to have 6x. Now, if we plug in 0 here, you still get 0 over 0. Alright, so let's differentiate again. We have x as x tends to 0. If we differentiate sine x, you get cosine x. If we differentiate 6x, you get 6. Now, plugging in 0, we're going to get cosine 0 over 6. And we know that cosine 0 is equals to 1 over 6. And then this is the answer to this question. So let's evaluate this one. Limit as x approaches infinity of x sine 1 over x. Now, a careful look at this equation, you see that it is not in quotient form. That is in the form of a over b. Alright, so we're going to write this to be in this form. So we're going to have limit as x approaches infinity. We're going to write it as sine 1 over x over, now this x, we are going to write it as 1 over x here, because by the time you multiply both the denominator and numerator by x, we are going to get back the original question. Now, having converted this into a quotient form, let's plug in the value of our limit. Let's know if we're going to get infinity over infinity. So we have that sine 1 over infinity over 1 over infinity. Now 1 over infinity is equals to 0. Then sine 0 is equals to 0. Then we have over 1 over infinity is equals to 0. Sine 0 over 0 is equals to 0 over 0. So we can go ahead and use L'Hopital's rule to solve this question. So let's make an assumption, right? Let u equal 1 over x. Now, if you plug in infinity sign here, you get 1 over infinity, which translates to 0. So invariably, our u is equals to 0. So we're going to write this question as limit as u tends to 0. Remember, u here is equals to 0. We are now dealing with u and not x again. Alright, so this is sine 1 over x is equals to u over, we have u here. So let's apply L'Hopital's rule. So you have that limit as u approaches 0. Then if you differentiate sine u, you're going to get cosine u. If we differentiate u, you're going to get 1. So plugging in the value of u, we have that cosine u is equals to 0 over 1. Cosine 0 is equals to 1. 1 over 1 is equals to 1. So we have that the limit as x approaches infinity of x sine 1 over x is equal to 1.